Hello and welcome to McLean 360. So in this video, I want to solve some couple of problems with you to illustrate the concept of false couple system. So sometimes they will tell you that replace a false by a couple, or sometimes a couple and then you have a false. Sometimes it becomes confusing. So how do you do that? Let's begin by looking at this problem. So the question is saying that um, we should replace the couple and force shown by equivalent or by an equivalent single force which is applied to the lever, and then determine the distance from the shaft to the point of application of this equivalent force. So how can I do that? So a better way to understand a force and a couple is that let's assume that I have this rigid rod right here. Okay, so let's say this is the rigid rod, and then at O, what do you see? You can clearly see that there are some two forces which are equal and opposite, right? So the word equal and opposite here means that, so this is what I'm talking about. I have 200 newtons, I have 200 newtons. And then the distance between them is the perpendicular distance, which is the diameter of the rod, right? It's given. And then he said, no, this distance from here to here is the radius. So if I want the diameter, the diameter is going to be what? The distance, that is in fact, that is the perpendicular distance. Okay, this is actually the one that is starting at O. So that distance is going to be 120 millimeters, which is the same as what? 0.12 meters. So what is this trying us? What is this is trying to tell us is that over here at the point O, since I have 200 and then I have 200 in this direction, these 200 and 200 forces are equal and opposite forces. Therefore, they will create some form of couple, all right? They will create a couple, and the couple moment due to these 200 and these 200 forces is given by 200 multiplied by 0.12. Now imagine a steering wheel. Okay, so imagine that this is a steering wheel. Imagine that this is a steering wheel, and then you are applying 200 here, and then you are also applying 200 here. It will cause the whole of this assembly to actually rotate in the clockwise direction, right? So we are saying that the moment due to this 200 and 200 is what? Going to be 200 multiplied by 0.12, and then the direction is actually clockwise. So 24 Newton meter, and the direction is clockwise or clockwise. Okay, so that is actually what is happening. Now I'm done with the couple force. So I'm done with the couple here. But I have another force, which is the what? The 400 newtons. So how can I bring the 400 newtons to this point? Okay, so this is basically what we are trying to say. We are saying that, okay, let me draw it again. Now I have this rigid rod again, okay, and this is point O. This time around, I want to ask myself, what is the effect of this single force here, this 400 Newton force? Can I bring the 400 Newton force at O? The answer is yes. But how can I do that? That is the question. The 200 and the 200, they are already at the point O, and they are creating some movement, okay? But the question is, can you bring the 400 Newton force to O? The question is, okay, so what if I create equal and opposite forces here? Since there is no force acting at O, I will create 400 here, and I'll create 400 here. This one, I have done it all. And you know what? The interesting part about this is, as soon as you bring equal and opposite 400 Newton force here, you have created a couple. Can you see that? Watch this. There is 400 here. There is also 400 here, separated by a distance. Can you see that? Clearly, what this means is that clearly I have been able to form a couple. So what this means is whenever you have a force and you've been asked to replace the force by a couple and then a force system at a point, what you have to do is you will create. So that's how we do it. You will create equal and opposite forces, okay? And that is what we are saying here. Create equal and opposite forces. And by creating equal and opposite forces, you know what? You have created a couple and you have also given, you also have a force here. Is that right? So basically, what happens is that, this couple that you have created will also tend to rotate the bar in the, so this is like the steering wheel analogy I was talking about. Imagine you are having 400 here, then 400 here. Let's say this is the rigid rod, this is 400 Newton, and this is 400 Newton. So imagine you have 400 in the opposite direction. Clearly, it is going to turn this in the clockwise direction. That's what we are saying. And what is the magnitude? In fact, the magnitude is nothing but um, the magnitude. Since the distance from here to here is 0.15, then I can use that distance. So I can use that distance to find the moment that this couple creates, or in other words, the moment of this 400 about this O is the same thing, okay? Because that is the perpendicular distance between the two forces. That is the perpendicular distance between the two forces, which is 0.15 meters. So what happens is that the moment, again, by the 400, so this is the 200 Newton force. By the 400, it's going to what? The 400 multiplied by what? The 0.15. And it's going to go what? That is clockwise. So 400 multiplied by 0.15. 60, okay? Therefore, the total moment that we need at O is what? So, okay, so let me write it again. So basically, if the question says we should replace it by a force couple, then this is what we are coming to do. So it means that if I want to draw the rigid rod again, this time around, I will draw the rigid rod, okay? I will draw the rigid rod again. But look at this. What we are trying to say is that the 200 force is going to cause a couple of 24 Newton meter, and then the 400 Newton force is also going to cause a couple of 60 Newton meter. However, the 400 force will also result in a force over here. Okay, so there will be a force over here, and this force is what? 400 newtons. And by doing this, I have been able to um, reduce this system to a force couple system at O. So that's how we do it. And if the question, so the question said what? We should determine the distance from the shaft to the point of application, this equivalent force. All right. So now, since I want to get the equivalent force, the distance, what I'm going to do is that I'm going to say that if indeed, so let's say this is what I'm saying. Let's say there is a certain distance along the shaft. Let's call this distance some distance d. Let's call it some distance d along the shaft. Then what this means is that the moment, so we want to know the if so basically what we want to do is that we want to know, initially you see that there was a certain distance which was, so this is what I'm saying, there was a certain distance here which is 300, right? But because this is actually a couple, if I want to now find the actual distance to this equivalent force, I can actually bring it over here, any distance at all, 400, right? Is that right? And then So the 400 is already here. Okay. Now what we are going to do is that take notice that the first one that we did, we thought it was here at this point B. But we are saying that there is a certain equivalent force over here, and then we are actually going to locate a certain distance D on the shaft. Okay. Now, if indeed we want to find the distance, then the moment that was created by that force will be the same as the moment that this 400 force is also going to create. So, in other words, we are just going to say that. But what is the angle? So okay, so the angle. This is what I'm trying to say. I want to draw it again so that you understand. All right. So to better understand it, let me draw the rigid rod again. So this is the rigid rod. Now we are saying that there is a certain force here, which is the 400 Newton force. So you want to ask yourself, is there a distance along the shaft which will create the same moment at O? But what is the moment at O? In fact, the moment at O is the sum of the moment by the couple and then the 400, which is going to be um, 24 plus 60. And what is that? So 24 plus 60, 84 Newton meter clockwise. So you want to ask yourself, is there a certain distance on the shaft? Let's call that distance D, where we can actually apply a certain force, which will actually create the same moment as the 84. That's the question that he's saying. The question was like, we should determine the distance from the shaft to the point of application of this equivalent force. All right. So basically, we need the distance. Let's call that distance D. But since there is an angle of inclination of 60 degrees, then we are going to take the moment about this 400 force, 400 Newton force, and the distance here is D. Therefore, the perpendicular distance from O is going to be D cosine 60. And we are saying that D cosine 60 multiplied by the 400 will be equal to the 84, which will create the same moment, okay? Therefore, the distance is going to be 84 divided by 400 cosine 60. And what is that? So it's going to be 84 divided by 400 cosine 60. And that gives us 0.42 meters, or in other words, 420 millimeters. So we are saying that at the distance of, okay, so we are saying that at the distance of 420, 420 along the shaft somewhere here, if I place this 400 Newton force, it will give us the same moment, okay? It will give us the same moment as the total moment at the point O. That's what we are saying. All right, so that is the end of the problem. Let's look at the next question. All right, so let's look at this problem. We've been asked to replace the loading system by an equivalent resultant force and couple moment acting at A. All right, so that is the problem given to us. How can we solve this problem? So we are actually going to apply the force couple system. First of all, let me start. Let me start with the 150 Newton force. All right. So this is what we are going to do. Whenever we take a certain force, we are going to create equal and opposite forces at point A. So for instance, with the 150 Newton force, I'll create an equal force, which is the 150 Newton force coming downwards, All right, so 150 Newton force coming downwards. And then I will create another force again, which is the same 150 Newton force, 150 pound force going up. Now doing this, the magic that I have done is that this 150 and this 150 will form a couple. Basically a couple simply means a force, two forces which are equal in magnitude and opposite in direction, separated by a small distance. So by creating equal and opposite forces about point A, I have gotten a couple, and then I have also gotten a force. Do you get it? So you see, by creating these equal and opposite forces, I've gotten a couple, and then I've also ended up by the same force at A. Therefore, this is going to, so if you want to know the direction, imagine this as a steering wheel, okay? And then let's say there is, all right, so imagine this as a steering wheel, and then let's say that there is a force of 150, another force of 150. Clearly, you can see that if this is 150 and if this force is also 150, separated by a distance of 3 feet, then what will happen? This is going to turn in this direction, right? And that direction is actually the clockwise direction, isn't it? So this is clockwise. Now, so let's do this. What if I pick the 150 force? Summation of force about A, what is it? It's 0, right? I don't have any force along the X. However, I have a force along the Y, and I'm saying that every force going up should be positive. So it's going to be minus 150. What about the moment? So the moment is going to be the couple moment. And the couple moment is going to be what? So the couple moment is going to be one of the forces, then I'll multiply by the distance, and it is what? This direction is clockwise. So it's going to be 150. So it's going to be 150 multiplied by 3. What is the answer? So 150 multiplied by 3, that is going to give us what? 450. So with respect to the to 450 pound inch or pound foot or feet. So and then it is clockwise. Okay, so it's clockwise. All right, so we are done with the 150 Newton force. In fact, we are going to do the same for all of the forces. When we take a force, we are going to create equal and opposite forces. So now let's come to the 200 force. Let's come to the 200 force. Now the line of action of the 200 force is coming towards point A, okay? So it is coming like that. So it passes through point A. If I try to create an equal and opposite forces, what will happen is that, so it's going to be opposite and then equal force, right? This is 200 pound. This is also 200 pound. However, what happens is that because the 200 pounds force is coming this way, this will cancel this. So with the 200 force, the equal and the opposite forces do not create a couple moment, or does not create a couple moment because of the line of action. It is passing through the point. Okay. So for the 200 force, the couple moment is going to be 0. Are you with me? And so with the 200, so sorry, 200 pound force. This is 150 pound force. This is 200 pound force. With a 200 pound force, summation of force along the X, every force moving here should be positive. For the 200, it's going to be negative because the force is coming that way, right? So it's going to be negative 200 pounds. There is no force along the Y due to the 200 force at point A. And then the couple moment is also 0 because the line of action passes through the point. There is no perpendicular distance. Okay, so we are done with the 200 pound force. Let's come to the 100 pound force. But you see, the 100 pound force, we can resolve it into horizontal. Okay, so with the 100 pound force, we can resolve it into horizontal and then vertical component. Now, with the vertical component, since the line of action of the force is here, you can say that this is 3, this is 4, and this is 5. Okay. Therefore, if I want to resolve it into the x, it's going to be 100 multiplied by 3 divided by 5. In fact, we have done all this in resolution of forces, how to resolve forces. This one is going to be 100, 4 on 5. Okay. So by the way, what is 100 multiplied by 3 on 5? So 100 multiplied by 3 divided by 5 will give us 60. So in fact, this one over here is 60. So 60 pounds. And then this one is going to what? 100 times 4 and 5. So 100 multiplied by what? 4 divided by 5. And what is that? 80. So this one gives us 80. So I'm going to get 80 pounds. All right. So basically that's it. So we are going to take these forces in turn. First of all, let's take the 60-pound force. Now the line of action of the 60-pound force is along this direction like this. This is the 60-pound force. So you know what I'm going to do? I'm going to stand at A. And then what I will do is that I will create equal and opposite forces for the 60-pound force. And let's see what will happen. Now watch this. If I stand at A and create an equal force which is in the same direction as the 60-pound force, okay, and then I create an opposite force which is, you know, in the opposite direction, you know what has happened? Interestingly, the opposite force which I created will cause what? A couple, right? Because now I have, don't forget that the 60-pound force can be traced over here due to the principle of transmissibility, which states that the line of action of a force can be transmitted on a straight line. So what this means is that I have 60, which is in this direction, 60, which is in the opposite direction, forming a couple. So you can think about this as a steering wheel where the force here is 60 and there's another opposite force here which is 60. Okay, so you can think about that. This is 60, this is also 60, and the distance between them is 4 feet. All right, now doing that, what happens is that, so the 100-pound force, we have divided it into 60 pounds and 80 pounds. So with the 60 pound at A, the summation of force, look at it, this is going to come, so we are saying that the 60, the positive 60 and the negative 60 is going to create a couple. So it's going to be left with this force. Okay, this one is going to create a couple moment, and then I will also get another 60-pound force. So about the x, summation of force along the x, positive in this direction, is going to be 60 pounds. Okay, but there is no force in the y, so that one will be 0. However, the couple moment due to the 60-pound force is the 60 here and the minus 60, which is in this direction. And the distance between these two forces is the 4 feet. So I'm going to take one of them. Clearly, if I take the rotation vector, what is it going to be? There is going to be rotation in this sense, right? This one is going to come this way, right? If I try to rotate it that way, which is what? Clockwise. Okay, so that is clockwise. So it's going to be 60 multiplied by what? So it's going to be 60 multiplied by 4. And what is that? So 60 multiplied by 4. And it's 240, isn't it? So the answer is 240. And the 240 is actually in pound foot. And the sense of direction is clockwise. Okay, the sense of direction is clockwise. You see how we are doing it? So let's look at the 80-pound force. Okay, let's look at the 80-pound force. So with the 80-pound force, I mean the resolved component of the 100 along the y, the line of action of the 80-pound force is in this direction. Okay, it's in that direction, the vertical direction. So what I'm coming to do is that I will stand at A over here, create equal and then opposite force to the 80. Is that right? So this 80 pound is 80 pound. Now by creating equal and opposite forces, what happens is that the opposite force which I created is going to form a couple with the 80 pounds I already have. So that don't forget that the line of action of a force can always be traced on a straight line. So the force can even be traced up to this point. And then we can still say that the force is acting at this point, right? Now what happens is that this 80 here, which is opposite to this 80, will form a couple, okay? And then I will get a force here. Do you get a concept? So basically, if I use the steering wheel analogy again, then I'm going to get something like this. And then the 80 is coming downwards, and then this 80 is pushing it up. Therefore, it's going to rotate in this direction, which is the counterclockwise. And the distance from here to here is 3 plus 3, which is 6. So 6 feet. This is 80 pounds, and this is also 80 pounds, right? And then I've gotten a force of 80 pounds. So all the time you have to create equal and opposite forces. One of them will form a couple with the initial force, and you will also get a force again. So that's why we call it the force couple system. So with the 80 pound, it's going to be what? Summation of forces along the x is going to be 0. Summation of forces along the y, every force going up. All right, so that is going to be what? 80, eh? It's going to be 80 pounds. How about the moment? So the couple moment caused by the equal and opposite forces. So by the opposite force is what? So this one is going to be 80 multiplied by 6, isn't it? 80 multiplied by 6. And then, the direction of this is actually against the clock. Or in other words, this is counterclockwise or anti-clockwise. So it's going to be 80 times 6, and the direction is actually anti-clockwise. So 80 multiplied by 6, which is what? 320. All right, so 80 multiplied by 6 is 320 pound force foot or pound feet. And the direction is this time around is counterclockwise. Okay, so that is actually the answer. But let's find the resultant. First of all, let's find the summation of x, the force along the x. So I have minus 200 along the x, and then I have what? 60 along the x. So the resultant is going to be minus 200 plus 60, which is minus 140. And then I have my summation of y. That one is going to what? So I have minus 150 here, and then I have 80, right? So minus 150 plus 80. So that's going to be minus 150 plus 80. That gives us minus 70, right? Pounds. So this is pounds, and this is also in pound, right? Therefore, the resultant force is going to be the square root of minus 140 squared plus minus 70 squared, and that's going to give us what? So the square root of minus 140 squared plus minus 70 squared. So that's going to be what? 156.52. So 156.52 pound. That is the resultant force acting at A. And then how about the resultant couple? So the resultant couple, let's assume that counterclockwise is positive. Then we are going to get what? So this is clockwise, so negative. This is also clockwise, so negative. Minus 450 minus 240. This is counterclockwise, so positive. So in other words, minus 450 minus 240 plus 320. So 370, right? And this is minus. The minus sign is just telling us that the actual couple moment is what? Clockwise. All right. So basically, what this means is that after doing everything for all of the forces, all these forces are creating a certain resultant force at A and then a certain moment. And so the force is here 140 along the X and then 70 along the Y. And then there is a couple moment which is going clockwise. And this couple moment is what? 370. Okay. So 370. This is pound. This is pound. This is pound inch. Oh, this is not Newton meter. This is pound inch. A pound feet. Sorry, pound feet. All right. So that is the problem solved. So whenever you have been given a force and a couple system, always try as much as possible and create equal and then opposite forces. That's how we solve it. All right. Let's look at the last problem. All right. So let's look at this last problem. Let's look at this last problem. All right. So four people are attempting to move a stage platform across the floor. Okay. Now, if they exert the horizontal forces shown, we are to determine A, the equivalent force couple system at O. So that is O. Then B, the points on the X and Y axis through which the line of action of the single resultant force R passes. Okay. So how can I do this? Now, we are just going to use the force couple system again. Let's start from point A. Since we are going to take the equivalent force couple system at O, we are going to start from A. All right. Now, okay, no, let's start from the O itself. You see, there is this 300 Newton force right here, right? So what happens is that if I want to cause or if I want to create a force couple system, I will create an equal but opposite. So this is what I want to do. I'll create an equal and then as at the same time I'll create an opposite force at O, right? But what happens is that so this is what I'm saying. You create a force here, which is 320 Newton, then create an equal and opposite force. But what happens is that this 320 will take off this 320, and there will still be what? Another 320. So what this means is that along the X, I have 320, a positive in this direction. However, along the Y, I do not have any force. And then also, I don't have any couple moment. And the reason is, the 300 force, that the equal and opposite force I created were opposite to each other. Okay, maybe let me do this. The 360, you may get it better. So let's look at the 360 Newton force. So what I'm going to do is that at the 360, with the 360 Newton force, I'm going to walk all the way from here, and then what I will do is that at O, since we are saying at O, I will create an equal but opposite force, which is what? The 360. So the 360 will come here. So I'll create 360 here, and then an opposite force, which is also 360. Now watch this. This 360 which I have created right now, this one, the opposite one, this is the 360 I initially had. I created an equal 360 and an opposite 360. So this initial 360 and the opposite 360 I have will form a couple, okay? Will form a couple. So this is basically what I'm trying to say. Let me say I have, let's say I have a steering wheel right here. The 360 force is here, and there is also another 360 force here. So if I have 360 force here, I also have 360 equal and opposite forces. What will happen? I will form a couple, and the distance is actually this distance, which is 1650 millimeters or 1.65 meters. And this would tend to rotate in this sense, which is what? Clockwise. So for the 360 force, I'm going to get, so at O, I will get a certain force here, which is the same 360 Newton force, right? So with the summation of force along the X, I will get the same 360 Newton force. Do you see? But okay, and then at the Y, I don't have anything. But the moment, what is going to happen? This 360 here, and then the opposite 360 I created is going to form a couple. And that is what I've done here. You get it? So that's how we do the force couple. All right. So it's going to be 360 multiplied by 1.65. 594. So I'm going to get 594 Newton meter, and the sense of rotation is clockwise. Okay. So I'm done with the 60 Newton force, 360 Newton force. Let's look at the point at C. Let's do C before we go to B. So with the 140 Newton force, let's look at that one. So with the 140 Newton force, what I will do is that I will create equal, which is so I'll create equal and opposite forces. Okay. So the equal force to the 140 newtons is this one, right? Then I'll create an opposite force. And this opposite force is also 140. So I'll create an opposite force over here. Now, what we are trying to say is that the opposite force will always form a couple. And then I will get my equal force, which is the same as the initial force here. So I will get a couple plus what? The force. And this is going to cause rotation, right? So to understand this better, I always use the steering wheel analogy. This is what? 140, and then over here I have what? 140 Newton. So this is going to create a couple, and it's going to rotate in this sense, right? It's going to cause rotation in this sense. All right. So basically, that's how it works. The distance here is 2200 millimeters. So that is uh, 2.2 meters, isn't it? So 140 multiplied by 2.2, that is the moment, and it is counterclockwise. So it means that with the 140 force along the X, the force is 0, And then along the y, the force is going to what? 140. So 140 newtons. And then the moment of the couple that it creates about 0.0 is 140 multiplied by 2.2. What is that? So 140 multiplied by 2.2, that gives us 308 Newton meter. And the direction is actually counterclockwise. So the direction is counterclockwise. All right. So that is the direction. It's actually counterclockwise. Now, let me do the last one, which is the 280. Okay. Okay, so let's look at the 280 Newton force right here, right? So I'm going to resolve it along the x and then along the y. And what is it going to be? 280 cosine 45. And that is 197.9899. So let's say 198, okay? 198 Newton. All right. I think similarly, this is also going to be 198, right? If I do sine 45, it's going to be the same as cos 45. Yeah. So let's say 198. Now about O, with the horizontal force, let's do the horizontal force first. The line of action of this force is this, right? So what I will do is that I will create equal, which is 198 newtons. Then I'll create opposite, okay? I'll create an opposite force here, which is 198 newton, but then it is opposite. What we are trying to say is that the opposite force, if I try to draw the line of action of the opposite force, it is actually like this, 198. And we are saying that it will form a couple. It's just like something like this. Going to form a couple here, which is 198, and this is 198. And the distance between this to this is 1.65, okay, 1.65 meters. And then the sense will be what? Clockwise. All right. So basically, with the horizontal force, the force, so the fx will be what? At point O. We are talking about at point O. Since this opposite force is causing a couple moment here, then the only thing left for us is this one, okay? And that is what? Positive. So it's going to be 198 newtons. Summation of force along the y is 0. And then the moment that is going to cause is this moment we have just find out, which is what? 198 multiplied by what? 1.65. What is that? 326.7. So I'm going to get 326.7 Newton meter. All right. And this moment we said is what? Clockwise. Okay. So then let's do the same 198 again. Now this is actually the vertical force. Let's see how the vertical force is going to be. So with the vertical force, it's going to come this way. So we are going to create equal 198 and then opposite 198. Okay. Now we are saying that if I trace the line of action of the opposite 198 to come like this, all right, and then this will form a couple with this, all right, will form a couple with it. So what is it going to be? All right, so We are saying that if the line of action here will create a couple, so if I use the steering wheel, then this will come this way, all right? In other words, okay, let me do it this way. I have 198 here, then I have 198 here, separated by a small distance, which is 2.2 meters. This is Newton, this is Newton. In fact, this is going to cause this to rotate in the counterclockwise or anti-clockwise direction. Is that right? So for this one, so it's going to be what? The y direction. So for the x direction, the force will be 0. But for the y direction, the force is going to be what? That is the 180 itself, isn't it? Don't forget that we are talking about point O. Now, since the line of action of the force coming down is creating a couple with this, then the one coming up is the only one left, right? The positive one, this one, the only one left. And that is what? 198. So 198 newtons. How about the moment? So the moment is going to come from here. 198, 198 multiplied by 2.2. So that gives us 435.6. That gives us 435.6 Newton meter. But let's go back and check. Is it counterclockwise or clockwise? This is counterclockwise or anti-clockwise. All right. So we've been able to do this. What is the resultant force? So if I want the resultant force, I will sum the force in the x and put it together. How many forces do I have in the x? I have 360 along the x, and then um, I have 320. So 320 plus 360 plus 198. What is it? So I have 320 plus 360 plus 198. That gives me 878. So the sum of the forces along the x is 878. And then about the y, going to what? So 140 plus 198. Yeah, I think that is it. So 140 plus 198. Okay. So 140 plus 198. And that gives us what? 338 Newton. How about the moment? Summation of moment. Okay, so let's do this. Let's first of all find the resultant of the force. It's going to be square root of 878 squared plus 338 squared. That is how to find the resultant. 878 squared plus 338 squared. Okay, and that's going to give us what? 940.81. So 940.81 Newton. And where will the resultant force act? Okay, so now let's sum the moment. So the moment is going to be what? Let's say counterclockwise is positive. So it's going to be 594 is clockwise, so minus 594. 308 is anti-clockwise, so plus 308, then minus 326.7, then plus 435.6, right? And then what is it again? Yeah, or okay, that is it. And then what am I going to get? So minus 177.1. With the minus sign, minus 177.1 Newton meter. The minus sign is just telling us that the resultant moment is what? Clockwise. Okay. Now, having done this, you know, The question is saying we should find a location. Okay, we should find a location along x and then y. So let me say that it's somewhere here. We don't know. Let's call the distance x. So the distance x and then the distance y, where the resultant force is acting. We don't know. But one thing that we know is that if that is indeed where the resultant force will act, then okay, so this is what we are saying. So we are saying that if I want to find where the resultant force will act, then the assumption is that if I take the moment of the resultant force in the plane, then it must be equal to the resultant moment. Okay. So we are saying that if I take the moment of the resultant force, then it will be, or it must be the same as um, taking um, taking the moment, uh, equating it to the sum of the moment. Okay. All right. So how can I find the moment of the resultant force? All right. So let's say that the resultant force, we don't know, but let's say that the resultant force is somewhere here. Okay. It's somewhere here at a distance x and then a distance y. Then what we are going to do is that, so let's say that the moment is R cross F, okay, of the resultant force to be equal to summation of the moment. All right, so I can rewrite the resultant force as a component. So it's going to be 878 along the I plus 338 along the J. All right. So basically, this is what I'm trying to do. The R is Rx plus Ry. Okay. And where Rs and Ry is the position I need to walk so I get there. So Rxi plus Ryj. Then I'll cross it with the force, the resultant, sorry, which is 878I 338J. And this will be the same as the resultant moment. And this moment is actually clockwise. And since it is clockwise, it's going to be K. It's going to be minus K, sorry. No, the minus sign is to show that it's actually clockwise. All right, let's do the cross product here. When I do the cross product, I cross I will be 0, and then ij will be k. So 338 rx k. Then again, j cross j is 0. So I'll do the j cross I, which is minus k. It's going to be minus 878 ry k. This is minus 177.1 k. All right, so even though they are all in k, what happens is that um, I have 338 rx minus 878 ry. K should actually be minus 177.1 k. In other words, 338 rx minus 878 ry is going to be what? Minus 177.1. Okay, so in order to solve this equation, um, all right, so basically how I can solve this problem is to set, so when s is 0, in other words, rx is 0, what will happen? We have minus 878 ry to be minus 177.1. And from here, our ry is going to be what? our RYY, sorry, our RY is going to be 177.1 divided by 878, right? And that gives me 0.202 meters above. So it means that I would stand here, I'll stand here and go all the way here, 0.202. How about X? So I can say that, when my Y is 0, what am I going to get for X? 338 Rx to be equal to minus 177.1. So that Rx is minus 177.1 divided by 338. And that is going to be what? So it's going to be minus 177.1 divided by 338. And that gives me minus 0.524. So minus, um, sorry, minus 0.524 meters. So in fact, this one means that left of O to 0.524. All right, so it means I will stand here and walk 0.524. That is where so it means that the resultant force is passes through this point. Okay, so this is where the resultant force at O. Okay, so maybe something like this passes through this point. All right, so that is how we will solve some of these problems. Thank you very much for watching.